Good morning, all. Thank you very much for joining us for today for Module 5. We're just almost past halfway of this series of webinars with Brent. Welcome, Brent, for coming back. We're lovely to have you here. And like I just mentioned, for those who are joining as we speak, if you haven't received my email regarding part 4, please drop me an email or just give me a chat. I'll get your details and I'll send you the link to part 4, which Brent has so nicely recorded for us, and it's on our YouTube channel, including the risk assessment checklist sheet that he has provided. And I'll give you that as well. Well, I'm not going to take a lot of your time. I'll be handing over to Brent now. Brent, the floor is yours.
Hey, thanks, Wes, and welcome everyone. Thank you here for being part of part 5 of this module. And in this module, module 5 is actually looking at understanding the common health risks associated with machinery. And in the session, we will look at the machinery safety risk approach to chronic and health risks. We will explore some of the more common health-based risks with machinery, and we'll understand about how that relates to the machinery safety standards. And more importantly, is we'll have a real good conversation about how the hierarchy of controls could be applied around managing the health risks with machinery. And the reason why I gave this its own module is because in general, our risk assessment approach to health risks is not as good as what we do around physical risks. So if I think about machines, machines by their nature, they can cause acute harm, they can cause chronic harm, and obviously the work design can also cause psychosocial harm. And how we manage those risks are actually governed by the standard here, the 4024.1303, which is the risk assessment standard. And what that standard basically explores, it basically says that you have to understand the occurrence of harm and the two-way effect. And it separates the difference between an event, so an event which typically can lead to physical harm, although it can be a health-based harm. And with health-based risks, for us to understand the chronic side of that harm, we have to look at it through the lens of time. So in that example, if I think about harm, we need to understand the relationship between the hazard and the worker. And we need to understand the exposure, so how frequently they are exposed to that hazard. And we need to understand the time of that exposure. So if I think about noise, for example, basically noise travels. So the further away the person is from the source of the noise, then the less the level of the noise. But with noise, the frequency or the time of the exposure is also a relevant component. But in all these situations, the reason why we struggle with noise is because of the risk perception of us as people. So typically, we see danger as being something that is within close proximity or close time. And we struggle to perceive the danger with health-related risks because it happens either over long periods of times or distance. So example, if I think about noise, an event could be an explosion on a machine. And that's an impact-based event where there's a sudden loud level of noise being released. And that could have immediate physical effect on that worker around hearing loss. Versus them being exposed to a low hum of noise on that machine over 10, 15 years. We don't see that daily exposure as being a risk to us, but the effect of that is accumulating or building over that time. So I want to explore 4 common health risks that I see with machines. I'm going to touch on noise, ergonomics, vibration, and hazardous substances. There are many other types of common health risks, and depending on the type of machine, we would explore those in different ways. So for example, in a previous session, we explored a standard for conveyors. And if you looked at that conveyor standard, you will see that they list a whole lot of the health-related risks around a conveyor. But in general, when I think about generic machinery, these are the 4 most common health risks that I come across: noise, ergonomics, vibration, and hazardous substances. Of course, there's also lighting, but we should always have good lighting. But lighting's in that cluster as well. So there are standards that focus on some of these components, and there is a standard under the 4024 series called 1401, which looks at the ergonomic principles. So that looks around design of machinery from an ergonomics perspective. And in other words, we should design, particularly say conveyors, where the height of that conveyor basically allows people, if their job is to do sorting on that conveyor, then the height of that conveyor should be ergonomically designed to support those people. And there's another standard called 1303, which looks at how to reduce risks from hazardous substances emitted by machinery. So I can think of a lot of machinery where, as part of the production process or part of the material process, a hazardous substance is being introduced. So for example, cutting, that some form of coolant or oil is introduced, or during sanding or spraying, some type of solvent is introduced, or even things like glue. So those types of substances are there as part of the machine process, rather than treating it as a separate hazardous substance itself, because how it is stored and how it is used is completely different. So if we think about the hierarchy of controls, the hierarchy of controls is asking us to always apply those higher order controls. And if I just touch on that, what we're really saying is that if we apply those substitution, isolation, or engineering controls, those controls are focused at directly how the hazard releases energy. And those controls are either trying to prevent the energy from being released, those controls are trying to respond to the energy being released, or those controls are trying to recover from the energy. So when I think around a health risk, for instance, around dust and fumes, the extraction component is around preventing workers from breathing in those dust or fumes. The monitoring of the levels may well be a response component, or sirens being activated, or beacons going off. And then the recover component might be how extraction knocks up that next level, or how we might close off certain areas to prevent it from going further. But those other controls, those things we were trying to administrate or we're trying to provide PPE, those things are really about trying to influence human behavior. They don't control the hazard, they're trying to influence the human's interaction with that hazard. Or, as I would say, they're trying to influence the hazardous situations that arise when workers are having to do their normal work on that machine. And if I was to explore that in a different lens, by applying those higher order controls around substitution, isolation, and engineering, we're allowing both the machine or the person to fail, but for that failure to happen safely. Where we are relying on those administrative controls and that PPE, we are really reliant on the human capability and the human capacity. And the work that I do, I don't talk about human error, I talk about human reliability. I ask the question, how reliable does a human need to be on that machine to avoid being exposed to a hazard? And if that reliability is high, then what it tells me is that we actually have weak defenses around substitution, isolation, and engineering. And I challenge all of us as health and safety practitioners that when you do a risk assessment, rather than just accepting administrative controls or PPE controls, the challenge I give to you is why could we apply those higher order controls? Because to me, an administrative control or a PPE control is really acting complementary to a higher order control. So let's explore some of those examples around those health risks. So here we go, managing noise. Well, no surprise, a good substitution would be buying quieter equipment. Sound good? Isolation control would be either moving people away from the source of the noise or moving the source of the noise away from people. So for instance, machinery that is driven by pneumatics, by air, why does the compressor need to be near the machine? Why can't we move that compressor outside the building? An engineering control around noise would be things like silencers or enclosures. Once again, the purpose there is that if we know that noise drops for every meter, then if we can put in silencers or barriers or some form of enclosures, that means we can actually reduce the distance the noise can travel. And by changing that, then we're changing the decibel rating of that noise. From an administrative point of view, we know that maintaining that machine and that equipment can also reduce noise. But that maintenance is an administrative control because it is reliant on someone remembering to perform that maintenance. If that machine could self-feed itself, then that would be an engineering control. If that control requires a human component, it's an administrative control. And then lastly, if we can't substitute, if we can't isolate, if we can't engineer, then to complement our administrative controls, we would then put in place some PPE. But sadly, what I see is we start with PPE. And with machinery, this is where we need to think about why can't we apply those higher order controls. Ergonomics. Okay, we can obviously, if we eliminate people from the process through automation, we don't have an ergonomic hazard. It's difficult to apply a substitution control because people typically are a whole body. If I think about isolation, some good examples could be things like the seating or the standing position. In other words, the person can only access that part of that machine from this given location. And that given location has been designed for that purpose. So for instance, if someone needs to do an inspection, Then we have a portal or a hatch that is made that prevents someone from straining or reaching in. Then we have some engineering controls, which are things like mechanical assistance or restraint devices. I don't really see many of them these days, but previously we might have seen that where someone is having to sort, they actually wear a restraint that doesn't allow them to go past a certain point. We have administrative controls, which is around things like worker rotation and load limits. And other controls around worker positioning, assistance, and housekeeping in those situations. Now imagine there'd be some PP controls, but typically those PP controls would be for people with pre-existing conditions in that space. If I was to explore vibrations, and this is a really interesting one, because vibration is not something that we look at quite often around machinery. I know we talk about issues around muscle mass, around portable devices quite a bit, but when I think about fixed machinery, we don't really have a close look around those vibration issues. So once again, an elimination would be to remove the vibration its components. A substitution would be to use hydraulics or pneumatics rather than mechanical. That will reduce vibration. An isolation control, an engineering control would be around the use of rubber isolators or fixings. If I briefly mention fixings, quite often I see machines that are not fixed to the ground. If they have parts that move, that will create a vibration. Then we have our typical administrative controls, which are around worker design, rotation, and limits. And then we have PPE, things like anti-vibration gloves or absorbent material on the floor, those types of things. Once again, go back to it. What are we doing to apply those higher order controls rather than the typical administrative controls? And the last one is around managing hazardous substances. So no surprise, if we can't get rid of the substance, then we should look at a substitution. So we should use alternatives that are less harmful. We can apply good isolation around those substances through good stories and containment. And so often I will see drums of a product sitting next to the machine. And I ask the question, how are those drums put into that location? What happens if a drum spills over? Where are workers standing in proximity to that drum? All those things cause issues around that. And then we have engineering controls such as access, extraction, and ventilation. And then we move down into those administrative controls and those people controls that are all governed within the safety data sheet itself. So my preference there is for us to look higher up the order of controls rather than just accepting that it's always been that way and we can't affect change. So questions from anyone around that? We can either, in the chat box, sorry, I just missed that. Bring that up. So
Yeah,
we're just saying,
I'll open up the lines as we speak and
sure,
ask questions. But yeah, please use the chat function or the Q&A function, guys. But you're right saying that, Brent. We see on a daily basis, we see a lot of this risk management, control, hierarchical control. We start at the PPE and administrative side of it instead of looking at the higher ups. Well, sometimes we do want to look at the higher up. It's just that there's all sorts of other barriers in place.
Yeah, remembering that these things that we're doing is because we failed to take the opportunity at the design phase of the machine. So we're always having to make up for the failure at the work design. And I know I'm being a bit critical of people, but that is what I constantly see. You know, designing out hazards, not only is that good for people, it also means that you don't have that same level of human reliability that's needed. And when we have a tight labor market, where at the moment, if you get a pulse, you can get a job, all these issues become apparent because of poor work design on that machine. And what do we then supplement that? We supplement that with more supervision. We supplement that with more training. We supplement it with more monitoring and more observations.
And that just incurs more cost in any event at the end of the day.
Absolutely. Yeah. You're adding waste into the system, whereas in fact, we could address that by going slightly higher up.
Yep. No, that's it from my side. I think Matt Jones has got a question.
Hi, Matt.
Yeah, g'day. I just had a observation or question around the reliance on human capability and capacity in the hierarchy of controls. I think those were the terms that you used back in that slide.
Yes. Yeah. I like the word capacity and capability.
Yeah, absolutely. The other factor that I often see around that, and I'd be interested in your thoughts about it, is perverse incentives around work, where we see people having an unspoken, I guess, culture of getting the job done quickly. It may not be driven by the employer. It may just be the workmates around them. People who are embarrassed to stop a process in order to do an intervention safely, or situations where there's a job and knock and sort of situation or an incentive for production bonuses. I've seen situations like that where it's not necessarily linked to capability or capacity, apart from maybe discipline, but also just cultural aspects of as I say, perverse incentives.
Yeah, I think once again, I think there's two parts of it. Workers will always want to be effective and efficient. That's a given. Particularly around machinery, there is a routineness around machinery that actually encourages us humans to want to be effective and efficient. Otherwise, it's freaking boring. Because that routineness is an issue for us. But then we also have the other side of it, which is it is the system that people operate in that drives their behavior. And what I see, Matt, is we have a thing, we call it the common cultural practice. So I remember looking at a network environment where they had a variable speed controller on the conveyor.
Yep.
Well, not surprising that when someone new comes on board on that networks line, the other workers speed up the conveyor to find out if that worker can handle the pace.
Yep, and they're also incentivized to get from 9 lambs to 10 lambs per minute, or whatever the case may be.
Now, that is, in my world, that is not the fault of the worker.
Yep.
The system has allowed that to become present as part of what I call common cultural practice, because what the workers are exhibiting is normal work. They just didn't decide at that very moment to change something.
Yep.
So and if we were to bother to go out in that environment and look at normal work, you would see all those conditions present. Whereas we tend to go out and we try to observe behaviors. I try and go out and observe conditions. So the environment that people are operating in, what does normal look like? So the reason I use the word human reliability is, you know, how reliable does a human need to be for that job to be less dangerous, or for that job to be safe?
Yeah, and the other sort of observation that I've seen around that is quite often it's the most conscientious thinking worker that you have to be most concerned about, because they're the most likely to put themselves in hazards to do what they may think is in the best interest of the employer.
It is that effective efficiency trade-off that exists. But what's interesting is that trade-off is more prevalent in routine work rather than in dynamic work. So in dynamic risk, the workers are doing constant problem solving.
Mm-hmm.
In routine work, they're basically doing that effective efficiency because of the mundaneness or the routineness of that. Now, This is not a health and safety issue. Okay, this issue has been well recognized in quality and lean and manufacturing for decades. I would encourage people to look at how the quality side of it worked. And shockingly, when we hear things like go to the Gimba and quality, that means that management goes down and looks at normal work. And it asks workers, is the stuff we're doing, are we doing it to make you successful? Because quality realizes that routineness of the job can affect quality over time. What quality realizes, they have a concept called TAC time, TAC, and TAC time says that job should be able to be performed within this range of time. And if the job is being done over time or under time, that is an opportunity to learn. Now, for us, if workers do the job quicker, we see that as innovation. And quality, when work is done outside that TAC time, the organization wants to know why, because that could either be an opportunity to change standard work and improve quality, or it could be a threat to quality. Was that helpful, Matt?
Excellent, thank you.
Right.
Do we have a last question from anybody before we close off today's session? I do have one thing just to mention before we close off. So last question from anybody?
Did people find the health bit of it useful? Because it's not really spoken about much.
It's very underrated in my experience. I guess the other part is, in terms of exposures to hazards, getting a hold of a good occupational hygienist can often be really important. I know it's quite difficult to do at the moment. There aren't very many of them out there, but finding a good occupational hygienist around exposure to substances and doing proper exposure quantification from machinery can be very useful.
Oh, okay, absolutely. But I also say having a health person, having an engineer getting together and saying, how can we affect change? That's even more powerful, because there is a huge overhead around the cost of health monitoring. And if we could drive that need out through redesign, that would actually save a lot of money and save a lot of potential suffering.
Completely agreed. Yep.
Great. Thanks for that, guys. Just for your info, guys, Shopcare is working on a preferred service provider / equipment list. Hopefully that will be a public available in the next couple of months. So, for example, the things like occupational hygienist, you want to know which ones are good, you'll be able to find them on our website. But before we go, I just want to thank you, everybody, for coming today again. Our next session is the 7th of March, and that will be module 6 or part 6. And then lastly, guys, we had to schedule a new date for the final part, which is part 8, and that date is the 5th of April. If you have not registered yet for part 8, please do so. If you want me to send you the details, let me know. I will, or otherwise just go on our website and register for part 8, which is on the 5th of April. Thank you very much yet again, guys. Thank you very much, Brent, for your time. We appreciate it. This will be uploaded to our YouTube channel, hopefully by the end of this week. And if you want the link for that, I'll be sending that out hopefully very shortly. And if you want to share that, please do so, and people can have a squiz at it for those who have missed it. Until then, guys, thank you very much. Brent, any last words?
No, look, thank you guys for hanging in there. My apologies for the week. I'm now fully over COVID from my North American tour, so I promise to make the next one.
Excellent. Great. Thanks, guys. Have a good one. See you next time.
Thank you. Bye.